In this lesson, we are going to review how to identify the domain and range of a given graph. Remember that domain refers to all x values on a graph, and range refers to all y values. Before we begin, notice the difference between these three example graphs. The first graph has 5 discrete or separate points. The middle graph has 1 point and a line with an arrow at the end. The third graph also has 5 points, but every point is connected with lines. Because these graphs have different features or characteristics, we will also write their domain and range in different ways. Let's start with the first graph. This graph has 5 separate points, which means we will need to write their domain and range, or their x and y values, separately. Let's start by labeling the points. This point has an x value of -5 and a y value of +4. This point has a x of 1 and a y of 4. This point would be 4, 1, down here, 3 on the x, and -5. Sorry, that's positive. +3 and -5. And finally, -1, -2, because it's on the left and down. Again, because the points are separate, for the domain, we're just going to identify each x value and each y value. Because the points are separate, we will also write the numbers separately. We can see that in option C. We can see all of the x values written separately and all of the y values written separately. Now let's look over here at graph number 3. Here we have 5 separate points, but in this case, they're all connected by these line segments. These lines indicate that there are many more points between the given points. Our domain and range needs to represent all the points on the graph, the ones shown here, and also the ones in between on the lines. To do this, we use inequalities. Let's start with the domain. Remember, the domain represents the x values, or the horizontal spread of our graph. I'm going to use 2 post-it notes to help determine the horizontal spread or domain of this graph. So just like the axis, I'm going to read this graph from left to right, and I notice it starts here, and I have lots of lines and points until here, where the graph just stops. all of my points and all of my lines are contained between these two limits. We represent that with the following notation. This notation indicates that the domain, or the x, is in between these two values. On the left, our lessermost value is -2. On the right, our greatest x value is +6. So this inequality shows us that the domain, or the x, are all the values in between -2 and +6, which we can see in option B. We can use the same strategy for the range, but this time, now I'm going to look at the vertical spread. So I'm going to use my Post-its. And this time I'm going to read the graph from bottom to top. And I can see it starts down here at -3. And we have lots of values up until this uppermost point, which is at y = 5. So I'm going to take those two limits and pop them into my inequality here. Again, the lower limit is -3, and the upper limit is +5. Again, this notation means that my range, or y values, are all the numbers in between -3 and +5. So we can see both of these in option B. Right. Finally, it's time to look at graph number 2. This graph is different from the other graphs because it has a line with an arrow at one end. This arrow means that the graph continues off the paper. On the other hand, it has a point. This indicates the graph stops on this side. So if I were to use the same inequality notation for this graph, I can see that my x has a leftmost limit, which is at -3, but on the right, there is no limit. The arrow shows that the graph continues beyond the paper. So, because of this arrow, because there is no limit, we do not have a second part to this inequality. X is simply all the numbers that are more than or equal to -3. All of this side of the coordinate plane. Notice my final option A looks a little different. These are the same, except here the variable x is written first. So if I'm going to swap my variable, if I'm going to move it to the other side, that means I also need to flip or reverse the inequality symbol. And that will give us the answer that you see in option A. Again, this means that the domain is all the numbers greater than or equal to -3. We can use the same strategy with the range. Again, I'm going to look for the lower and upper limits of the graph. I can see the upper limit stops here at +4. But the lower limit does not exist. remember, the arrow shows that the graph continues and continues and continues. So there is no lower limit to my inequality. I'm just going to say that the range is all numbers less than or equal to positive 4. And we can see that on the graph, that the line starts at positive 4 and then covers all the numbers below it. So we can see option A refers to the middle graph. Let's look at 2 more examples, and then you can try the other examples on your own. Let's see if we can use one of the examples at the top to help us. Which graph here is similar to this problem? That's right. Graph number 1 is similar to this graph in that all the points are separate. Remember, when the points are separate, we're going to write each x and y value separately. So let's do that. Down below, my domain, my x values are going to have separate numbers for each separate point. So let's go ahead and find those coordinates. This point is at the origin, so that's 0, positive 4, 1, positive 4, 3, positive 1, 5, negative 5, negative 3, negative 2, and negative 5, 0. So let's go ahead and write out each of those x values. And we're going to write them in order from least to greatest. So my least is my biggest negative number. Then my next negative number, and 0, 1, 3, 5. Again, my order is from least to greatest. That's simply left to right. So you start on the left, negative 5, the next point, positive 3, the next point, 0, 1, 3, and 5. I'm going to do the same thing with the range, the y values. I also want to write these in order, but because the y-axis is vertical, my lesser numbers are going to be at the bottom of the graph. So I'm going to read from the bottom to the top. My lowermost y is negative 5, then negative 2, then 0, then 1, and then 4. Notice I have 2 4s. I only need to write them once. So I'll just write 1 4, even though I have more than 1 point with this y value. I only need to write it one time. All right. So we can see 5 separate points. 6 separate points. So we have 6 separate x values. Okay. Are the points on graph B separate? No. These points are connected by line segments, much like the star example we saw in graph 3 above. So let's use this example and this notation to help us write the domain and range for graph B. Again, because all the points are connected and there are no arrows, I know that I'm going to use this notation. My domain, I know I'm looking for the horizontal spread of the graph. So I'm going to take my post-it notes and define the left and right limits. I see the graph starts on the left at -3. So that's my lower limit. And it has lots of values up until +5, where the graph stops. Okay. So my domain is all the x values in between -3 on the left and +5 on the right. We'll do the same thing with the range, but this time we're going to look vertically. And again, because we're going from least to greatest, just like we did in our other set, we're going to start from the bottom and read upward. So my lower limit of the graph is down here, and it goes all the way up to here. This is the uppermost limit of the graph. So the lowest y value is -5, and the highest y value, or greatest y value, is +4. So this means my range is all the y values in between -5 and +4. Okay, I hope these examples will help you do the problems on the back.